Hey everybody, here's this week's tutorial. It's going to be in two parts. First I'm going to cover the quiz in-class project that we had this week, and then I'm going to do a second tutorial that covers the new material. So first let's look at that quiz and see what was in it. First of all, I gave you an example of what the finished product looks like, and here it is. Again, it's a simple sequencer that randomly generates a beat pattern and plays it. So let's look at how that was constructed. First of all, create a simple sequencer with game function, beat, and playhead actor, so we can easily do that. Game functions beat and playhead. Our beat, we can give some sort of size like 20 by 50 pixels. Our playhead is tall and narrow, so I'll make it 2 pixels wide and 500 pixels high. And our game functions, I'll give some color so that we can differentiate it from the other actors. Game function spawns 20 beat actors using a loop. These notes are placed at random locations within a 16-column and 4-row grid. So our game functions has a loop, and that loop is going to loop 20 times. So we can create an integer attribute and call it beats, the number of beats, and we can say while the number of beats remains less than 20, this loop will happen. So then within the loop we need to change that attribute numBeats to numBeats plus 1 each time a new beat is created. And some of you missed this aspect in the quiz. The loop is dependent on the number of beats being less than 20, but there's no automatic function that will increment this value each time a new beat is created. We have to do that manually with a change attribute. Each time a new beat is created, we need to increment the number of beats attribute. And then we're going to, of course, spawn our actor. What actor are we spawning? We're spawning beat. And now here's that grid question. Let's look at it again. 20 beat actors. These notes are placed at random locations within a 16-column and 4-row grid. So we know that there's 16 columns and we know that there are 4 rows. So our randomness gives us a value between 1 and 16 corresponding to the column, and one and 4 corresponding to the row. But of course we need to scale this up to the pixel locations of each beat. So since I made my beats 20 pixels wide, I'll place them on a grid that's larger than 20 pixels, and I made them 50 pixels high, so I'll place them on a grid that's larger than 50 pixels. So for instance, random 1 through 16 times 25. That means if the random generates a 1, it'll be 25 pixels from the left edge of the screen. If it generates a 2, it'll be 50 pixels. If it generates a 3, it'll be 75 pixels. Same thing here. I'll multiply it by 60. so that if my random generates a 1, it'll be 60 pixels from the bottom of the screen. If it generates a 2, it'll be 120 pixels from the bottom of the screen. And we'll place game functions onto the screen. And one other thing we need to double check is that these spawns are relative to the scene, not to the actor. We want this to be independent of the game functions actor location. And there we go, random assortment of beats. Now these are all kind of crunched to the left edge of the screen. If I wanted to shift them over, I can just globally add some pixels. I'll shift everything to the right by 100 pixels. So I'm saying random 1 through 16 times 25, and then whatever this generates, I'm adding an additional 100 pixels just to shift things over to the right a bit. That's too far, so I'll go back and just shift them 50 pixels to the right. There, that's nice. And each time I refresh, I get a new random assortment of 20 beats. Cool. All right, so let's see what the next step is. And as always, you want to save your work in progress. As you go, because even for me, you know, computer programs hang, you lose your work, and that's very frustrating. So when the playhead touches a beat, the beat plays a sound. Each of the 4 rows plays a different sound. Okay, so I'm going to put my playhead onto the screen. There it is. And to get my playhead to move from left to right, I'm just going to use the move behavior. Let's see what it does. It moves nicely. Okay, slow it down a bit. Cool. And the playhead moves left to right across the screen and loops back to the left edge after it's swept over the notes. So this is something that a lot of you had difficulty with. I'm skipping to the last step, but since I'm working on the playhead right now, I might as well do this. This is going to be a rule. There's multiple ways to do it, but the way we looked at in class is to use a rule. When the playhead's X position exceeds a certain value, which we don't know yet, then we'll have it jump back to the left edge of the screen, which would be a change attribute. So when the X position is greater than some value, then the X position resets to some value. So if we want to scan the whole screen, we can just say when the X position of the playhead is greater than the game display size width, then it will jump back to 0, and this will cause the playhead to go all the way across the screen, jump back to the left edge. When its X is greater than the left edge, then it jumps back to 0. But this is not going to play our beats in a rhythmic way. We'll solve that problem later, come back to it. For right now, we have the playhead scanning across the screen. So let's go back to this. When the playhead touches a beat, the beat plays a sound. Each of the 4 rows plays a different sound. So first of all, let's get some sounds in here. So here I have some bass drum, hi-hat, hi-hat open, and snare drum. I'll take those and bring them in as sounds to GameSalad. And as always in GameSalad, I need to import either as music or as sound. In this case, we're importing them as sounds. They're not long music files, they're not soundtracks, they're going to play underneath a scene. They're individual sounds that we're going to trigger so that we're importing them as sound. And there they come in, and we can listen to them. Nice. So how do we get this one beat actor to play 4 different sounds? Well, we use a rule. The first part of the rule is, of course, the playhead has to hit the beat. So when we say actor receives event overlaps or collides with actor of type of playhead. But we also want to determine which sound is going to be played. So here we can add an additional rule and say when all of these conditions are valid, when the playhead hits it and something else, then we play a particular sound. So since it's based on where the note is on the screen, we'll do it based on an attribute, and that attribute will be the beat's Y position. So I know that my bottommost row is going to be at 60. And how do I know that? Because my game functions creates 4 rows. The first row is at 60 pixels, the second is at 120, the third is at 180, and the fourth is at 240. 4 possible random values, each one of them multiplied by 60. So I go into my beat and I say, if the position is 60, meaning if that beat is in the lowest row, then we will play sound. We'll play the bass drum sound. And turn the volume down a little bit. Now let's just see if that works. So our playhead's not coming around rhythmically yet, but it's working. You can hear that kick drum there. And we can just copy and paste this rule, and let's put the snare drum in next. We know our next row is at 120 pixels. We'll have it play the snare drum. So now I should get bass and snare. And our third row is at 180 pixels, and that can be our hi-hat open. And our fourth row can be at 240 pixels, and that'll be our hi-hat closed. And let's see how that works. Great. Like it. So now what's our next thing here? The color of the beat actor is different depending on which of the 4 rows is in. Okay, so there's a lot of creative ways to handle this, but basically it's a rule and a change attribute. We can say, for instance, when the vertical position of the beat is 60, then we'll take all the red out, for instance. Color red is 0, and that's going to make my kick drums blue. Great. And we can just continue this line of thinking. When my Y position is 120, we'll take out all the green. Now I took a little bit of a different approach when I did it, and rather than having it make the color based on an exact pixel location, I just simply used a change attribute without a rule, and I said change the redness, for instance, to the Y position divided by 240, because I know my highest row is at 240. So that means my highest row will have 240 divided by 240 is 1 maximum redness. My middle row is at 120, or my second row is at 120, so that will be 120 divided by 240 is 0.5. That'll be half the amount of red. So redness will scale based on where we are on the screen. My bottom has very little red. My top has maximum red. And then the other thing I did, just for fun, in mine, is I created an inverse relationship with a different color. So for instance, my blue, I set it to 1 minus self-position divided by 240. And that's a simple way of taking and inverting a value that's between 0 and 1. So 1 will become 0, 0 will become 1, 0.5 will remain 0.5, 0.25 will become 0.75. And you can very easily figure out mathematically why that is. And then I get a nice color range from the top to the bottom. So as the final step, I want to make this work rhythmically correctly. Because right now I have this dead black space to the left and to the right of my beat, and so it's not coming around in a rhythmic way. So let's take a look at how to do that. First of all, I know that my very first column of beats is going to be when the random gives me a 1, so it'll be 1 times 25 plus 50, or 75 pixels from the left. So instead of jumping all the way back to 0, I'll make my playhead jump back to 75 pixels. And my rightmost beat is going to be at 16 times 25 plus 50. So what is that? So that's, bring up the old calculator here. 16 times 25 plus 50, 450 pixels. So instead of letting it go all the way to the edge of the screen, I'm going to stop my playhead at 450 pixels. Now, this is not quite the right answer, but it's close. Why is it not quite the right answer? Because in Game Salad, actors are measured from their center. So my playhead is actually starting in the middle of beat 1 and ending in the middle of beat 16. So what I really want to do is start at the left edge of beat 1 and end at the right edge of beat 16. How do I do that? Again, it's simple math. My beat is 20 pixels wide, so it's got 10 pixels to the left of its center and 10 pixels to the right of its center. So to make things work out, I'm going to have my playhead loop around when it reaches 460 pixels. That's the right edge of the 16th beat. And I'm going to have it loop back to 65 pixels. That's the left edge of the leftmost beat. And now I should have a rhythmically correct. Sequencer. Very nice. And that's it. That's the solution to the quiz. As always, there's always at least 3 ways to solve every problem. In the case of the color, I gave you 2 ways. In everything else, I gave you 1 way. To me, these are the most simple and self-explanatory ways based on the material we've covered in the previous tutorials, but however you find the solution is absolutely fine, and there's room for a lot of creativity there. So in the next tutorial, I'm going to move on and look at how we expanded the sequencer and the new concepts that I want you to learn this week and incorporate into your own final Game Salad projects.